This is chapter 6.2, which is the simplex method and maximization problems with problem constraints of the form less than or equal to. Basically, we're doing problems of the same form we saw for 6.1, but the method's going to be a little more concise. It's more complicated, but it's definitely more concise. So let's see that. But first, let's recall a few things. So this example, we've seen a problem like this before. In fact, I think we've been seeing the same example before. We want to maximize this objective function. So let's denote that objective function with these problem constraints. Now remember, in this section, all of these problem constraints will be of the form less than or equal to for 6.2 anyways. And then these were the non-negative constraints. And what did we do? Well, we started with this inequality system, which was an I system, which was x1 plus 2x2 less than or equal to 32, 3x1 plus 4x2 less than or equal to 84. We converted it then into an E system, which was an equality system. Basically, you just add these things to make it equality, and the things were called slack variables. So let's add, let's say, S1 to the first equation to make this equality, like this, and then add, let's say, S2 to the second equation to make this equality, just like this. Good. And then what? Oh, then we created a table. And with our table, we plugged in certain x's to be 0, certain s's to be 0, and we were able to conclude that those corresponded to corner points on the geometric way of seeing it. When s is negative, those are corner points that are outside of the feasible region, so they're not really corner points. And then we plug in those x1 and x2 values into p to see if p is maximized or minimized. So to find the largest value or the smallest value. Here we want to maximize, so we're looking for the largest value of p. We're going to be doing the same exact thing in this section, but instead of creating a table, we are going to create what is called a simplex table. In fact, it's normally referred to as simplex Tableau. So it's a little different looking, so I'm going to see that right now. All right, so here it is. This is our E system, and now this is our what is called the initial simplex Tableau. So the initial just means that we just began to transform it into this form. And now what we're going to do afterwards is we're going to use basically matrix operations to get it in a more simplified form so that we can actually arrive at a maximum p value. Right now p is 1. Well, and in fact right now we have it's equal to 0. We're going to find out what x and x1 and x2 values will correspond to a maximum p value. Let me try to explain how I arrived at this. So first off, usually lines are drawn here and here. Okay. Now, the first one I think should kind of be okay, because if you think about it, this is just the same as this, but in kind of augmented matrix form. So the coefficients of x1, x2, s1, and s2 respectively are 1, 2, 1, and 0. Notice there's no p, so p is always going to be 0 for each of these first two rows, and equal to, well, that number, 32 and 84. So again, if you look at the second row here and look at the coefficients for x1, x2, s1, s2, and p in this equation, they're in that order. 3, 4, 0 because there's no s1, 1 because there's one s2, and 0 of course because there's no p in these equations. So why p is 0 here is pretty obvious. We just basically needed a column for p for the bottom row. Now let me try to explain the bottom row. The bottom row is really just our initial objective function, okay? Only we move things around so the zeros on the right. So I'm subtracting these terms to the side. So hence the negative 50x1 and the negative 80x2. And of course there's no s1 and s2 in that equation for the objective function, so there's 0 there. Okay, why did I label these as s1, s2, and it should be s1, s2, by mistake. So why did I label these as S1, S2, and P? Well, these correspond to the intersections of those. So if you look at S1 and S1, they intersect at 1, S2 and S2 intersect at 1, and P intersect at 1. Now, this value here, this is going to be our maximum P at the very end of doing all this process, which I'm going to describe in a bit. Now, why these are S1 and S2 right now? Well, we want them to actually be X1 and X2, but that'll happen later. And this is, honestly, the labeling here isn't super important. All we need to know is that this is our goal. This is our maximum. So that's what we want to find at the very end. So it's 0 right now, but it's going to turn into something later on. Now, as far as what I was saying here about S1 and S2, like I said, it doesn't really matter too much. But basically, these are going to enter. And it sounds weird, but just kind of bear with me for a moment. So these X1 and X2 variables are going to enter here, and then they're going to exit here. Now, it's very possible that X1 doesn't actually exit here. X1 could exit down here. And similarly, X2 can exit on top instead of on the bottom. So the order may not be as you think it would be, but the whole point is that there is an entering process and an exiting process. And it has to do with something called a pivot. And this is probably the most complicated part of this section. Well, it definitely is the most complicated part of this section. And we're going to see that right now, but let me just say this before we begin. Performing a pivot is essentially applying matrix operations given certain parameters, but we'll have to do it as many times as you have variables. So here our variables are x1 and x2. Those are our main variables we had constraints on before we introduced our slack variables. And once we perform the pivot on, well, I guess in this case twice because there are two variables, then we'll be done and we'll actually have the maximum that we wanted at the end. So let's see that right now. Right, so the first thing in this pivoting process is to find first the pivot column, then the pivot row. Where they intersect, well, they'll intersect at what is called the pivot element. So how you find the pivot column is you look at the bottom row here of P, the P row, and you look for the most negative number. So what's the most negative number? It's the smallest number basically, it's negative 80. Negative 80 is the most negative. So negative 50, but then negative 80 is a larger negative, we say. So this is our pivot column. And it's because it's the most negative entry. So let me just try most negative in parentheses here. Okay, once we have the pivot column, well, first off, the variable that it corresponds to above is the entering variable. So let me just denote that here. So now we say that this is entering. So this variable is now entering. And what is our pivot row going to be? Okay, so the pivot column we find by finding the most negative value for P. The pivot row is a little more complicated, but basically you look at the last numbers here and you divide them by the entries in the pivot column. So here, if you divide 32 by 2, you get 16. And here if you divide 84 by, well, the entry that's in that pivot column in this row would be 4. So 84 divided by 4 is 21. And then you look to see which one is the smallest quotient. So the smaller of the two here is definitely 16. So this is the smallest one. And the one that corresponds to the smallest will correspond to the actual pivot row. So now this will be the pivot row. So that's an indicator of what the pivot row is. Perfect. So once we have our pivot row, well now here x2 is entering. Now this will tell us which row x2 will be exiting. So it'll exit in the pivot row. So here now it's going to exit. Exiting. So this S1 will be replaced with x2 after we're finished, basically. And where they intersect, where the pivot row and pivot columns intersect, is actually at the pivot element. So here 2 is known as the pivot element. Okay, so now actually how you perform the pivot operation is you look at your pivot element, you divide everything in that row by that number so that this is a 1. If it's already a 1, you don't have to do that. But in this case, we're going to do that first. Then we're going to make each of the entries in this column 0, except for the element. So the element's going to stay a 1 after dividing everything in that row by that number. So dividing this by 2, we'll leave this being 1. Then we're going to perform row operations essentially so that the other entries in that column are 0. Other entries, not this one, the other ones. So let me write the procedure here so we can see that. Okay, step 1 is definitely the shortest step in this process. So we're going to divide everything in this row by 2 because that's the number 2. So to make it 1, we need to divide it by 2. So divide everything by 2 will leave us with 1/2. 2 divided by 2 is 1. We get another 1/2 under the S1 column. And then 0 divided by 2 is 0, so we get a 0 for these. And then finally 32 divided by 2 will be 16. Perfect. And now for step 2, we're going to add multiples of this row to these other rows to make these numbers below this 1 in our pivot column. This is our pivot column after all, 0. So we want that 4 to be a 0 and then negative 80 to be a 0. So how do we do that? Well, I'm going to have to multiply the top one by negative 4 and add it to the bottom one. So let me just write the work here and we'll write the corresponding matrix. So let's see. So the top row will stay the same. So it's going to be 1/2, 1, 1/2, 0, 0, 16. Hopefully everyone's following along as well. You probably should for practice, because otherwise it's just going to be a lot to look at. So we're going to multiply the top by negative 4. So we'll get negative 2, negative 4, negative 2, 0, 0, and then 16 divided by times negative 4 is negative 64. Okay, and then we're going to add that to the bottom row, to the middle row really. So this is 3, 4, 0, 1, 0, 84. Now when you add these together, you get the following. You get 1, 0, negative 2, 1, 0, 20. So that's our new second row. So let me write that here. 1, 0, negative 2, 1, 0. And am I missing something? No, we're good. And then 20. Okay, now what? Well, now what do I do? What do I multiply to the first row to make this one 0? Well, if I multiply this by 80 so that this 1 is an 80, and then add it to this one, the 80 and negative 80 will cancel. And that's what I did really here. I wanted to make this a negative 4, so when you add it to the second row, they'll cancel as well. So I multiplied everything in that row by negative 4. So making this 1 makes the row operations a little easier. Notice we'll get fractions involved, but that's okay. We can handle fractions, hopefully. So I'm going to erase this work and then rewrite the work for the third row. Okay, so for the third row, like I was saying, we need to multiply the pivot row by 80. So 1/2 times 80 is 40. That's going to be 40, 80, 40. 0 times 80 is 0. 0 times 80 is 0. 80 times 16. Well, 16 times 4 was 64. So 16 times 8 is double that, so that's going to be 128. But since we're multiplying it by 80, we gain a 0. So that's going to be 1280 actually, when multiplying 16 by 80. Then, well, the bottom row stays the same, negative 50, negative 80, 0, 0, 1, and 0. Adding these will give us our final third column. So we're going to get negative 10, 0, 40, 0, 1, and 1280. So let's see if we have space for that. Negative 10, 0, 40, 0, 1, and 1280. Okay. Perfect. So now what? Are we done? We are not done. We've only performed one pivot, and how many pivots do you have to perform? The amount of variables. Since we have x1 and x2, there are 2 variables, so we need to perform a pivot 1 more. So we're going to perform the same process. Now we need to kind of start over. So how do we even start? We began by finding our pivot column and pivot row. We're going to do that again. So I'm going to clean all this up. This is my resulting matrix here. So I'm going to write this in place of where this one was, and we'll repeat the process. All right, so before continuing with our next pivot, I forgot to mention something. Now, notice I kind of lost labeling when I did the process earlier. But here, with these labels, we have this. Now recall that x2 was our entering variable because this was our pivot column, and our pivot row was the first row. So we saw that x2 entered and it exited here in this row. So we're going to replace where there was an s1 and now with x2. Similarly with x1. So x1 is going to have to exit here, but it hasn't exited yet because we haven't performed the pivot yet. So right now this is still an s2. The top one was an s1, but we performed our pivot, so x2 exited and replaced s1. So that's how the labeling works as far as that goes. So now to perform our pivot. So there are, again, 2 steps. The first step is the easiest. Divide everything by, well, the reciprocal of your pivot element. But now what's a pivot element? Well, how do we find our pivot column? We look for the most negative entry in the bottom row, and it's this one. So this will be our pivot column. What is our pivot row going to be? Well, it would have to be this one, like I said, because x1 would have to exit where s2 is. But how did we find it before? Well, we divided 16 and 20, well, there were different numbers back then, but we divided these numbers by the coefficients of the column. So let's do that here. If you divide 16 by 1/2, that's the same as multiplying 16 by 2, so that's 32. And if you divide 20 by 1, you get 20. So the smallest one is indeed the row we wanted, that we kind of figured it would have to be. So this will indeed be our pivot row, making 1 our pivot element. And that's good because it's already a 1. If it wasn't, you'd have to divide everything by that. So step 1, we don't even have to do because it's already a 1. Perfect. So now we'll just jump to step 2. So for step 2, we're going to want to make these guys, let me point at them, 0. All of the other entries in our pivot column except our pivot element. We want to make those 0 by multiplying this pivot row by some number and adding it accordingly. So let's see if we can do that. So notice the second row is going to stay the same. So it's 1, 0, -2, 1, 0, and then 20. We have lines like this. That should be okay. Good. So now I'm going to have to write some work somewhere. Let me write the work over here, I guess. So to make this a 0, I would have to multiply this by -1/2. So if I multiply everything in this row by -1/2, we get -1/2, 0, -1/2 times -2 is +1, -1/2 times 1 is -1/2, 0, and -1/2 times 20 is -10. Perfect. Row 1 will stay the same. 1/2, 1, 1/2, 0, 0, and 16. And then adding these will give us our new row 1. And notice we get 0 indeed for the first entry, good. Then 1, and then 1 and 1/2, which is 3/2. 0 minus 1/2 is -1/2, 0, and then 6. Okay, so let me write that. So 1, 3/2, -1/2, 0, and 6. Perfect. So now let me erase this work, and I'll do the same process, but now for the third row. And so now, like I said, for the third row, what do you multiply this row by to add to this entry to make it 0? It's 10. So if you multiply row 2 by 10, we get 10, 0, -20, 10, 0, and 200. So I kind of squeeze that in, but hopefully we can see that. And now the bottom row will stay the same. That's -10, 0, 40, 0, 1, and 1280. Now adding these together gives us 0, 0, and that'll be 20, 10, 1, and that's 1480. So let's write that for our third row. So we have 0, 0, 20, 10, 1, and 1480. Perfect, we're done. Also, x2 has, well, x2 already exited. x1 has now exited. So x2 exited up here, and x1 exited down here. And here's what this tells me. This tells me now that this is our maximum. So we have maximize P, and the maximum is this. At what point does it occur at? Well, it occurs at these values for x1 and x2. Which one's x1 and x2? It really mattered where they exited, right? So x2 is 6, and then x1 is 20. So that means we have maximize, and our maximum p-value is p equals 1480, and it occurs at the point x1 equals 20 and x2 equals 6. So this ordered pair is x1 comma x2 like that. Perfect. So that's basically it. And we're going to do one more example, but that's really it for this section. It's just understanding the pivoting process. All right, so for this last example, this is an application problem, and it says the following. Let's read. A farmer owns a 100-acre farm and plans to plant at most 3 crops. The seed for crops A, B, and C costs $40, $20, and $30 per acre respectively. So 40 for A, 20 for B, and 30 for C. A maximum of $3,200 can be spent on the seed. All right. Crops A, B, and C require 1, 2, and 1 days per acre respectively. And there are a maximum of 160 work days available. If the farmer can make a profit of $100 per acre on crop A, $300 for crop B, and $200 for crop C, how many acres of each crop should be planted to maximize profit? All right, so I'm going to go to the board now, and I'm going to try to lay out the model for this problem, and we'll see what the constraints are. But remember, here we want to maximize profit, so we're going to have our objective function P be, well, the total amount we're going to make on each crop, which will be 100 for A, 300 for B, and 200 for C. So keep that in mind. After I make the model, you can always go back and rewind and look back at this and try to compare to see if you can come up with a model on your own. All right, so we have things labeled here. So I've kind of listed it out for us and created the model. But I'm letting x1, x2, and x3 respectively be the number of acres for each of those crops, A, B, and C. We want to maximize our profit, and this is what it is. It's 100 times x1 plus 300 times x2 and 200 times x3. And subject to these constraints, there's one for acreage, one for monetary, and then one for labor finally. And notice we also have non-negative constraints here because the amount of acres are always going to be non-negative, which makes sense. So if you want to go back and read the question and compare to this, you can see that these models make sense. Just to share with you some of the process when it comes to creating this Simplex Tableau. So first off, looking at the inequalities, it's pretty obvious to see what the coefficients are for each of these. Also, this is the I system. We want to make it an E system. We want to make it equality. So we have to add a slack variable. There's 3 of them, one for each equation, S1, S2, and S3. We're going to add S1 to the first one, S2 for the second one, and S3 to the third equation, meaning that there's going to be zeros for the other entries for the slack variables that are not present in those rows. Good. Now, what about P? Well, P was this equation. Remember how we do that? We always want this to be 0 to start in our initial Simplex Tableau. So we're going to subtract these to this side. So there's going to be 1P, no slack variables. And in these equations, there were no P's, so we're going to have 0 for under the P column in these rows. Okay. And all right, so we're looking at this equation now. So there's 1P, we want 0 on the left, so we're going to subtract these. We want 0 on the right, so we're going to subtract these over here. So we get negative 100, negative 300, and negative 200. Now the most negative of these is definitely this negative 300 here. So we're going to start with this pivot column. So this is going to be our column. And to find our pivot row, we're going to divide each of these numbers by the entries in each row in this pivot column. So we're going to do 100 divided by 1, which is just 100, 3,200 divided by 20, and then 160 divided by 2. So we get 100, here we get a 0 canceling, so that's going to be 160, and then here we get 80. So this is definitely the smallest one. So that means we're going to start with this row here. So this guy right here, this 2, is going to be our pivot element. So now we're going to pivot around this. So let me erase this and we'll continue. All right, cool. So now we know that this is our pivot element. So we're going to divide this row by 2 to make this pivot element a 1. And there it is. Now we're going to multiply this by certain values to start to eliminate each of these other entries in this pivot column. So let's start with the first one. If we multiply it by negative 1, it'll be negative. So let's make these negative. The zeros are still zeros, negative 1/2, 0, and then negative 80. And now the top row, we're going to leave as is. So it's 1, 1, 1, 0, 0, 0. Actually, there's 4 ones here. 0, 0, 0, there we go. And then 100. And now adding these together will give us our new row 1. So we get positive 1/2. So let me write the result above here. So we get positive 1/2, 0, positive 1/2, 1, 0, negative 1/2, 0 plus 0 is 0, and then we get 20. Perfect. So I'm going to erase this and we're going to do the second row and then the third. So for the second row, we need to multiply this by what? What does this 1 need to be multiplied by to make that 20 is 0? Negative 20. So multiplying this row by negative 20 will give us, let's see, 1/2 times 20 is 10, so it's negative 10, negative 20, negative 10, 0, 0. The zeros will remain zeros, of course. 1/2 times negative 20 is negative 10, 0. 80 times negative 2 is negative 160, so 80 times negative 20 is negative 1600. Okay? And we're adding that to the original row 2. So that's 40, 20, 30, 0, 1, 0. Actually, yeah. 30, 0, 1, 0, 0, 32. You gotta make sure things are lined up correctly or else you can make mistakes. Adding straight down, we get 30, 0, like we wanted, 20, 0, 1, 0, 0, and 32, 0, 0. Now finally for row 3, well I guess row 4. So for this fourth row now, we're going to multiply this 1 by 300 to cancel out with that negative 300. So multiplying all of these by 300, half of 300 is 150. That's 300. That's 150 again. That's 0, 0, 150, 0. And let's see, what is 3 times 8? That's 24. But we're multiplying it by 300, so there's a total of 3 zeros actually. Okay, and now we're adding this to the original fourth row. So it's negative 100, negative 300, negative 200, 0, 0, 0, 1, and 0. Adding these now, finally, we get 50, 0, negative 50, okay, good, 0, 0, 150, 1, and 24,000. Perfect. So we're done with our first pivot, and what exited? X2 entered and exited through this pivot row. So this is X2 now. Great. So now we need to do at most 2 more, because remember, we do a pivot operation, a pivot for each variable you have. So there's 3 here. Something I didn't mention that we'll actually see with this problem is that you don't always have to do exactly that amount. It just kind of depends when your process ends. When does your process end? It'll end when you stop having negative numbers here. Because remember, how do we figure out what our pivot column is? It's the most negative of these values. If there are no negatives anymore, then we're actually done. So it's possible that not every variable will exit. That just means that one of the values will be 0 for that max. So let's see that. Okay, so here is the last Tableau we ended up with. I just erased things and moved it up here. And now we're going to find our next pivot column and pivot row. So the most negative value here in the last row will indicate what our pivot column is. In fact, these entries are often known as indicator entries or indicator elements. I just haven't, said that. But anyways, this is our most negative value, so that's going to be our pivot column. Now, what is our pivot row? Well, again, we have to divide these last numbers by these entries. So let's see what we get. So we get 20 divided by 1/2, which is 20 times 2. So remember, when you divide by a fraction, multiply by its reciprocal. So it's 40. 3,200 divided by 20, that's 160. And then 80 times 1/2, actually 80 divided by 1/2 is 160. So yeah, the lowest one indeed is the first one. So what we have entering as our variable here is x3. So x3 is going to enter, and it'll exit S1. So we'll replace that once we're done actually doing the operations though. But know that we want this to be a 1 for our pivot element. So normally we would divide by a number, but here we have a fraction, so how do we make this 1/2 of 1? Multiply by 2. So if we multiply everything by 2 in the first row, we get 1, 0, 1, 2, 0, 1, 0, and 40. Perfect. And now what? Well, now let's see. What do we multiply this by to get rid of this 20? So for the second row, we need to multiply this by negative 20. So multiplying the top row by negative 20 will give us negative 20, 0, negative 20, negative 40, 0, negative 20, 0, and 40 times negative 20 is going to be negative 800. And write the original row 2. So it's going to be 30, 0, 20, 0, 1, 0, 0, and 3200. Adding straight down, we get for the second row 10, 0, another 0, negative 40, 1, negative 20, 0, and let's see, 32 minus 8 is 24. So that's going to be 2400. Okay, perfect. And now we're going to move on to the next column, the next row, which is the third row, and then finally the fourth row. Okay, so again, we're using this row, and what do we multiply this 1 by to get rid of this 1/2? Well, we'd have to multiply it by negative 1/2. And in fact, if you multiply this all by negative 1/2, you basically just get back the original row, but all negative for the first row. So it's going to be negative 1/2, 0, negative 1/2. That's going to be negative 1, 0, negative 1/2, 0, and negative 20. But again, if you want to see it like this, multiplying the first row here by negative 1/2 will give you this indeed. Adding it to the original row 3, we have 1/2, 1, 1/2, 0, 0, 0, well 0, 0, 1/2, 0, and then 80. Now adding these together will give us a new row 3, which is 0, 1, 0, negative 1, 0, 0, a lot of zeros, 0, and this finally is 60. One more row to go. Right, so multiplying this 1 by 50 will allow us to cancel this negative 50 here. So multiplying the top row by 50 will give us 50, 0, 50, 2 times 50 is 100, 0, 50, 0, 50 times 40 is 2000. And now the original fourth row, 50, 0, negative 50, 0, 0, 150, 1, and 24,000. When we add these, we get 100, 0, 0, 100, 0, 200, 1, and 26,000. And now we have actually completed our pivoting process for this this column here, for this entry. So what does that mean? Well, X3 entered and exited through the first row. So this is now X3. And we are actually completely done. We've done all of the pivoting we needed to do. Why? Because like I mentioned earlier, there are no negative indicators here now. So we can't even start finding our columns. Because remember, you look for the most negative number here. There are no negatives, so we can't continue with that process. And from there, we can't continue pivoting. So we're actually completely done. Meaning, this is our maximum, and it occurs at which values for x1, x2, and x3. It's a little funny, but just hear me out. So our max profit is P is equal to 26,000. Let me write the dollar symbol. Okay, and this occurs at x3 equals 40. So remember, x3 was how many acres you have for crop C. So it's 40 acres for crop C. x2 is how many acres you have for crop B, and that's 60. So x2 is 60, so 60 acres for crop B, and 0 acres for crop A, because there's no x1 here. x1 never entered and never exited. So actually it'd be x1 equals 0. So if you went back and actually plugged these values in for P, you'll indeed get 26,000. And it turns out this is our max because of the pivoting process. Okay, so that actually concludes 6.2. We ended it with this example. It was kind of a big example because it involved 3 variables, but at least showed that you don't always have to apply pivoting that amount of times, even though I mistakenly said that earlier. It's at most that amount of times because you may end early and you have no negative indicators. So I know it was a lot to follow, but again, if you tried these problems and followed along with me, it shouldn't have been too bad maybe, but it's just the row operations and the pivoting process. Understanding that is key, and we'll see that, again, get a little more complicated in the next section, and I'll see you then. Thanks for watching.